Welcome to that of the UG and PG students for the NET question solution 2024 regarding the organic chemistry. Now I am going to that of the first questions. The following reaction is the first test when the reaction take place from the reactant to that of the product. That is, this is the one type of the nucleophilic substitution reaction where the negative charge is created alpha to that of the cyanide groups, and the negative charge can be stabilized by the NO2 group and produces the product which can be stabilized by the stronger electron withdrawing group of the NO2 group. Here the methoxy group can donate the electron and hence the negative charge cannot stabilize. Similarly, the methoxy group meta to it, the negative charge cannot stabilize here. Similarly, the NO2 group meta to it cannot stabilize. So the negative charge can stabilize para to that of the NO2 group. That is, the stronger resonance will take place, and hence the nucleophilic substitution reaction is faster for the NO2 group when it is present at the para position. Similarly, if we go to that of the similar type of the nucleophilic substitution reactions where the potassium amide in presence of the liquid ammonia produces the benzene intermediate, and this benzene intermediate can undergo readily intramolecular cyclization reaction to get that of the indole derivatives after the isomerization. Similarly, another problem is that the chromium tricarbonyl complex can coordinated with that of the benzene rings and stabilizes the 18 electron rules, and this complex becomes highly susceptible for the nucleophilic addition reactions at room temperature due to that of the aromatic rings is highly electron deficient. So the spontaneous reaction of the nucleophilic substitution take place, and we get that of the benzopyrene derivatives. Now we are going to that of the next question regarding the absolute configuration determinations for the bicyclic systems. The absolute configuration can be determined by the 4-back positive rules, where the similar type of the 1, 2, 3, 4, that is this is the priority sequence rule. The OH group gives the highest priority due to the presence of the highest atomic number. Then this is the quaternary carbon, then the methylene carbon, and 4 is the lower priority. After the anti-clockwise rotation, regarding the 4-back positive rule, it gives that of the S configuration. Similarly, if we get that of the 4-back positive rules for that of the 1, 2, 3 anti-clockwise rotation, it gives that of the S configuration. Now the next problem is next question is the configuration of that carbon atom, where this becomes the 1 priority sequence, and this becomes the 2 priority sequence with the presence of the hydroxyl groups, and this is the 4 priority sequence. After the anti-clockwise rotation, one front positive rules, it gives that of the anti-clockwise S configuration. Similarly, this is the additional problem where the configuration can be determined for the camphor systems. Now we are going to that of the next problem regarding the nucleophilicity of the basicity of the heteroatoms. In case of the heteroatom, if we see that the different type of the nucleophilic donor center is there, where the nitrogen atom can donate electron to that of the methyl groups and produces the methylation can occur to that of the nitrogen atoms, or the pyridine rings, then methylation can occur in that nitrogen atoms, or the after resonance the negative charge can created to that of the C2 position of the pyrrole rings, and the methyl group can introduce here. So there is different possibility, but the stabilization of the positive charge after the formation of the product is very important. So here the negative charge on the pyridine rings is more accumulated on the nitrogen atom, as the nitrogen atom after the protonation the pyrrole nitrogen atom becomes anti-aromatic, but the aromaticity is retained in case of the pyridine after the methylation. So the methylation on the pyridine ring is more favorable compared to that of the methylation of the nitrogen atom on the pyrrole rings. Again, the C2 methylation cannot occur as the basicity of the nitrogen atom is greater than that of the carbon atom. So the option 2 is the correct. Similarly, the protonation can also occur in the purine system. Here the different type of the pyridine pyrimidine and the imidazole rings contain the different type of the nitrogen atoms, the basicity of the pyrimidine rings is more compared to that of the imidazole rings. So the protonation favorable and that rings compared to that of the this ring. Now this is the regioselective problem. That the different type of the regioselective reactions means the similar type of functional group can react under similar condition and produces selectively only one product, one center. Reaction can occur at the one center compared to that of the other center. Here the ester and acid group is present. We know that lithium borohydride only reduces the ester group compared to that of the acid group. So here this is the regioselective reaction. The acid group remain intact, but the ester group only reduced. But here in case of the silver carbonate silide benzene reflux, only the allylic hydroxyl group is oxidized compared to that of the non-allylic hydroxyl group. So these two are the regioselective reaction. But here the hydrogenation reaction, the only reaction possibility is there. But in case of the alkene iodolactonation reactions, the only the alkene center is present. So this is not C and D is not the regioselective reaction. Only the A, B is the regioselective reaction. These are the additional problems where the silver carbonate on silide produces the carbonyl group and then nucleophilic addition gives that of the lactone derivative. This problem is taken from that of the Carothers book. Similarly, here the regioselective oxidations on the 2-degree alcohol in presence of the primary alcohol. Here the sterically hindered alcohol is oxidized in this reagent compared to that of the primary alcohol. Similarly, another type of the regioselective reduction in case of the Wilkinson catalyst, where the less hindered alkene is reduced compared to that of the more hindered alkenes. Similarly, another is that lithium aluminum hydride in presence of the 35 degree centigrade. This is the condition dependent regioselective reactions. Here all these bond is the alkene bond and carbonyl bond can be reduced, but here in presence of minus 10 degree centigrade only the carbonyl group is reduced but the alkene group remain intact. This is the examples of that of the beta keto acid, where beta keto acid can be readily decarboxylated in presence of the carbonyl group alpha to that of the beta carbonyl, means the CO2H group present in the beta position, and the beta carboxyl group can easily decarboxylate due to the presence of the strong intramolecular hydrogen bonding and the stabilization of the negative charge. Here this carboxyl group is strong intramolecular hydrogen bonding and the negative charge is stabilized. So this decarboxylation is more easier compared to that of the other carboxyl group where the carbonyl group is absent. So after the decarboxylation the negative charge cannot stabilize. So the option 4 is the right. Now we are going to that of the stereoisomeric relationship problem, where there is no chiral center, but this compound shows the chirality due to the presence of that of the axial chirality, means the all symmetry is absent of these molecules. And if we determine the configuration, we can identify the molecules are either enantiomer or identical. After the configuration determination, if we look from that of the bottom side, the methyl group go to that of the up sides and the hydrogen group go to that of the down side, and this methyl group go to that of the left side and these hydrogen groups go to that of the right side. And if we get to the configuration 1, 2, 2, 2, 3 in the clockwise rotation, we get that of the this is the R configuration. Similarly, if we get that of the configuration, this is the R configuration. So these two molecules are identical. If we go to that of the additional problem, here the cumulated diene and the cumulated triene. The cumulated diene in presence of the unsymmetrical substitution always shows the axial chirality and it is the chiral molecule. But in the presence of that of the extra double bond, this is called cumulated triene, the whole molecule becomes planar and the molecule is optically inactive. These are the examples, additional examples where the molecule shows the axial chirality. If we go to that of the this problem where the boron has vacant p orbital that can resonate with that of the oxygen lone pair on the furan rings, and after the resonance the whole molecule becomes planar, but it contains if you counted the electron, this becomes 2, 4, 6, 8, 10 and 12, means that this contains the 4n pi electron. So it is the anti-aromatic, it is the anti-aromatic compounds, and the option 2 is the correct. Now what is the pharmacophore? Pharmacophore means the scaffold in which the molecules becomes bioactive. A pharmacophore is the abstract description of molecular features that are necessary for molecular recognition of a ligand. That is, the molecule can interact with that of the enzymes at the particular scaffold and produces the bioactivity. So the particular scaffold is very important for the any drug molecules or activity shows the any antibiotic molecules. This is the structure of the penicillin G, where the beta lactam unit is the pharmacophore unit. That unit is active for the any biological process. Now the structure of the what is the particular conformation of this cyclohexane given cyclohexane molecule. If we draw the different conformation, you show that the three molecules is that OH group in the upside, and this methyl group go to the downside, and this the methyl group go to the upside. And if we rotate on the anti-clockwise rotation and 120 degree, this methyl group come here, and this methyl group come here, and this OH group come here. So this molecule become identical to that of the given molecule. So the option 3 is the correct option. Now the following, what is the molecular orbital pictures of this correct molecular orbital pictures of the pentadienyl cations. In case of the pentadienyl cations, the molecular orbital picture means this there are 5 molecular orbitals, and one is the non-bonding molecular orbital, and one is the 2 is the bonding molecular orbital, and this is the anti-bonding molecular orbital. And if we go to the down to up, the first molecular orbital has no nodes, but the second molecular 1 nodes. And the given problem is that the molecule has only 1 node, and the pentadienyl cation has 4 electrons. So the homo highest occupied molecular orbital, this is the highest occupied molecular orbital, and so the option 1 is the correct option. Thank you for watching this video. Now we are going to know the NET examination solution 2024.